Hello everyone, this is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's topic under mathematics, do not forget to like, share, subscribe, click on notification button to have more of my video. Now today we are taking a topic on ordinary differential equation, and the aspect of ordinary differential equation that we are going to take is the solution of non-linear ordinary differential equation. And then the method we are going to use is called the Bernoulli method. We have other methods. We have what is called separable variable. We have the homogeneous method. We have also the exact and non-exact method. Now, before you can solve a given ordinary differential equation, you must be able to test which method will be best suited in solving that particular equation. Now, you must have a background on differential equation and integral calculus, and also you should be able to have a reference to the law of indices and as well as the law of logarithm, because the problem we are having on the board here is actually requiring those laws concerning the solution. Now, you are given this question. We are asked to solve s squared y prime minus sy minus y cube is equal to 0. Now, after testing, we discovered that the other methods are not suited in solving this problem. Please kindly refer to my other video where I explain how to use the other method in solving the differential equation. The one we want to solve now is the non-linear. Non-linear in the sense that we are having the power of y greater than 1 here. Now, before we can solve this problem using Bernoulli, I'm talking about Bernoulli method. Now, Bernoulli has standard references that we need to follow so that we can be able to appropriately use the method to solve this problem. According to Bernoulli, it says that y prime plus p function of variable x times y is equal to q function of variable x times y raised to power n, where the value of n must not be equal to 0 or 1. If the value of n is equal to 0 or 1, this particular Bernoulli equation will be rendered to a linear equation. So what we have here is called non-linear ordinary differential equation, ODE. Now, if you look at the given equation here, we need to reform this equation so that it will look like this format. What do? Here we have y prime. Here we have y prime times s squared. So that means we need to divide through by s squared. So dividing through by s squared, we have s squared y prime divided by s squared minus sy divided by s squared minus y cube divided by s squared is equal to 0. Here now, s squared cancel s squared. So we have y prime left. Here we have x divided by s squared, sy divided by s squared. So one of these s cancel this s. So what we are left with will be y all over x. Then minus y cube divided by s squared is equal to 0. Now we have been able to isolate y prime so that it will look like this. Now the next thing we need to do is to rearrange this equation in such a way that it will look like this standard form. So what we need to do is to take this one to the other side of the equation so we can have this expression. So what we have here now is y prime minus, I want to write this one using the law of indices. This is raised to power 1. By the time we carry this one up, the power that is positive will become negative. So this becomes ys raised to power minus 1 minus, when we carry this s squared up, this is a positive power. When you carry this up, become negative. So we have y cube s raised to power minus 2 is equal to 0. So taking this to the other side now, we have y prime minus yx raised to power minus 1 is equal to this minus. When you take it to this side, become plus. So we have we can write this one as x raised to power minus 2 y raised to power 3. Now if you look at this particular expression that I have here, if we compare it to this standard form now, if you relate it, that means this particular px function of y goes with this. In a nutshell, if you look at this one now, p of function of xy go with minus y s raised to power minus 1. So this y cancel this y here. So that means p function of x now will leave minus s raised to power minus 1 behind. Also, if you look at this one and this standard, q function of xy raised to power n is equal to this. That is s raised to power minus 2 y raised to power 3. By comparison, we can see that our n is 3. The n is 3. And we can see that y go with y. Then, therefore, q function of x will go with s raised to power minus 2. So, we've been able to isolate necessary functions here. Our n is equal to 3. Then our p of x is equal to minus s raised to power minus 1. And our q, the q of x here, is equal to s raised to power minus 2. Now, the next thing is for us to determine what is called integrating factor. Integrating factor. That is the next step. This is the first step. State this equation, then state this integrating factor. Integrating factor is normally in terms of a function of x and is given as e raised to power integral 1 minus n, then p function of x dx. So in this case now, as you have seen here, our p of x, we have already taken it to be minus s raised to power minus 1. Then our n is already 3. So 1 minus, when you put 3 here, this is 1 minus 3, that is minus 2. So this particular mu function of x can furtherly simplify as e raised to power integral 1 minus 3, that will give us minus 2, times p function of x. Our p function of x is this up there. So we substitute it there. Minus s raised to power minus 1. Then times with respect to x, that is times the x. Now, here now, the mu function of x now can be furtherly simplified as e raised to power. You see here, minus 2, minus times minus, that is plus. 2 times s raised to power minus 1 is 2 over x. So integral 2 over x dx. Now, let's move down to this side of the board. We can see that mu function of x is equal to e raised to power integral. You can see that here, this 2 is a constant. So I can take this constant 2 outside the integral sign. So we have 2, that will be 1 all over x dx. Now, from standard integration, integral of an expression of this nature is actually the natural logarithm. So this thing can be simplified as e raised to power 2 ln x. So the constant of integration, I do not want to put it, and there is a reason for that. So that means our mu now is equal to x. This expression I have here is called indicial equation. From the word indices. Indicial in the sense that this e is raising to this power. Now, according to law of logarithm, when you see a constant multiplying the log, that constant will become the power of whatever that is in front of that log inside. So this mu of x can be rewritten as e raised to power ln x raised to power 2. Now, I want to transmute this into what is called logarithmic form, in the sense that this ln x raised to power 2 is also called logarithm. This is logarithm. Logarithm to base e. Base e, natural logarithm. So I will now write it as ln x raised to power 2, which is log, is the same is the same as log of ln to base e of this mu, to base e of mu x. Now, since we have, well, I can write it as ln. Since we have ln on both sides, whatever that is inside will be the same. Therefore, my integrating factor mu, which is function of variable x, is equal to x raised to power 2. Now, the next thing we are going to do is to state the next step concerning the step at solving the Bernoulli equation. Please take note of this. This is the first thing that you must remember, and this is the second integrating factor that I've stated here. This is number 2, this is 1, 2, and the number 3 is what I want to state now, and that number 3 is to state the expression for the solution. According to Bernoulli, the solution form, the standardized solution form is y raised to power 1 minus n is equal to 1 all over integrating factor times integral 1 minus n times integrating factor, then times this particular function that we have here. You know that when we are doing the integrating factor, we use p of x. So when you are doing the standard solution, we don't pick p of x, we pick q of x. So times q of x dx, then I'm introducing my constant of integration here now, that is plus c. So that means this integrating factor will multiply everything inside. Now, our solution will be of the format 1, our n is 3, as I've already indicated the other time. So 1 minus 3 will give us minus 2 here. Then integrating factor that we have is this mu. Our integrating factor is that mu. That is 1 all over mu x multiplying integral 1 minus n times mu of x, then times q of x dx plus c. So it will multiply everything together with the constant of integration, that is plus c here. Now we have gotten expression for 1 over mu, expression for integrating factor. This mu of x is x squared, so we put it here. So I have y raised to power minus 2 is equal to 1 all over x squared multiplying integral n is 1 minus 2, n is 3, sorry. So 1 minus 3 will give us minus 2. So I have minus 2 times mu of x again. Mu of x again is x squared. So we put the x squared here by substitution. Then times q of x. We know that the q of x is what I stated here the other time. That is minus x raised to power minus 1. That's minus x raised to power minus 1. Then dx plus c. Dx plus c. So I want us to look at this solution step again. Here, this is the Bernoulli equation format, where n must not be equal to 0 or 1. Now, since we are given this expression that we have here, we can make it to look like this equation by isolating this y prime, so that it will have y prime like this. So we divide through by x squared. So when you divide through by x squared here, this is a y cube over x squared. So this become x raised to power minus 2 there, using law of indices, and this become x raised to power minus 1 using law of indices. So we have this expression. Now, if we compare this expression very well, we can see that P of x is x raised to power minus 1, and Q of x is x raised to power minus 2. So Q of x is x raised to power minus 2 here, x raised to power minus 2. Now, if you look at what we have here, minus times minus will give us a plus. So I can have something like 1 all over x raised to power 2 times this particular 2 can come, we can still leave it as from the law of indices, x raised to power 2 times x raised to power minus 2 will give us x raised to power 0. So I'm going to have minus 2x, no, I'm going to have minus 2, sorry, dx plus c. So when I integrate this one now, it's going from the standard integral. I'm going to have minus 2x, then plus c. You know, if you want to integrate, look at this. Take note of this. If you are integrating the x, it's actually integrating x raised to power 0 dx. And then from the formula of integration, let's say we have a x raised to power n dx. What you do is to add 1 to this power. So I have a x raised to power n plus 1. Whatever we have as power, we use it to divide n plus 1. Then we put our constant of integration for indefinite integral, because we are not given the limit. So that's the same thing here. You add 1 to here, to this 0. So it's going to be x raised to power 1 divided by 1 plus c, which is s plus c. So that's what I did here. Now, we now use this now to multiply everything throughout. Here now, 1 over x squared times minus 2x will give us minus 2 all over x, then plus c all over 1 over x squared times c, that's c over s squared. Now we can find the LCM. So we say y raised to power minus 2 can also, taking the LCM here, the LCM of x and s squared will give us just s squared. X in s squared will give us x. S times minus will give us minus 2x. Plus s squared in s squared will give us 1 times c will give us c. So, and this expression that I have here, I want to rewrite it in this place now. Look at it again. The expression I have down here, y raised to power minus 2 is equal to minus 2x plus c divided by s raised to power 2. This y raised to power minus 2 actually means 1 over y squared is equal to minus 2x plus c divided by s squared. Now I can take this y squared up. Anything I've done here, I can also do it here to balance my operation. So therefore, y raised to power 2 now, we have had this one. This one goes up. We have s raised to power 2 all over minus 2x plus c. Now, our solution should be in form of just ordinary y. So y is equal to plus or minus square root of whatever that we have here, s squared divided by minus 2x plus c. We say it as plus or minus square root of s squared will give us ordinary x, then all over square root of minus 2x plus c. This is the solution of the original question that was given here. Now, to round up this particular solution, I want us to take note of something. When I say y prime actually means dy dx, and it also means f prime of x. Please, I want you to take note of that. So this equation that I actually have as y prime is actually means s squared dy dx. So I am appreciative for taking your time, to learn on how to use a Bernoulli equation to solve non-linear differential equation. Please, before we go, do not forget to like, share, subscribe. Click on notification button to have more of my video. Please share my video on the Facebook, on the Instagram, on the WhatsApp, on all social media. Thank you. Counting on your cooperation. And for partnership, this is my OPE account number that is shown here. This is my phone number and this is my email. Thank you so much for having you. Have a nice day. Bye.